All right, let's jump right in. Today, we are talking about something pretty ambitious. A single formula that tries to mathematically pin down the very nature of existence. It's a huge idea, turning one of the biggest questions in philosophy into something we can actually work with.
So let me ask you, how do you prove something exists? I mean, it sounds like a question you'd debate with your friends late at night, right? But what if you could take that question out of the realm of pure thought and bring it into the world of math? The goal here is to stop treating existence as just this fuzzy, abstract concept and turn it into something we can actually measure and test. Well, here's the proposed answer. This is the equation of existence, and it comes to us from authors Lerry Alexander Villalobos and Emilia Jiménez Artavia. Now, the core idea is surprisingly intuitive. For anything to pop into existence, it has to satisfy two very different conditions. Let's break those down.
To really get what's going on inside this equation, we need to look at its three main ingredients. Each one has a really specific job to do in deciding whether something stays a what if or becomes an it is.
First up is P of P, which stands for probability. This is the one we're all pretty familiar with, right? It's just the statistical chance of something happening. We see it everywhere, from weather forecasts to sports betting. It's a straightforward value between 0, meaning no chance, and 1, meaning it's a sure thing.
Now this next one, pi of pi, is the secret sauce. This is possibility. And it's crucial to understand this is not the same as probability. This asks a different question. Is this thing logically or physically even possible in the first place? It's basically a simple on or off switch. If it's impossible, it gets a 0. If it's possible, it gets a 1.
And the final piece of the puzzle is the theta. This is the threshold. You can think of it like the bouncer at the club of reality. It sets the bar. It's the minimum score that probability and possibility, when multiplied together, have to achieve to get in. So here's a perfect way to see how they're different. Think about winning the lottery. The probability is ridiculously low, right? Almost 0. But is it possible? Yeah, of course. People win it all the time, so its possibility is a solid 1. Now think about a flying pig. The laws of biology just say no, so its possibility is a big fat 0. And in this equation, it doesn't matter what probability you assign it, because anything multiplied by 0 is 0. It can't exist. And that brings us back to the full equation. It's really elegant when you see it all together. A phenomenon, P, exists if its probability multiplied by its possibility is greater than or equal to that reality threshold. Simple as that. It has to be possible, and it has to be probable enough. So this is where things get really cool. This model, developed by the author known as LAEV, isn't just an idea trapped on a piece of paper. This isn't just a fun thought experiment. No, it's been turned into real open source code that anyone can go and download and play with right now. And get this, the entire logic is captured in this one single line of Python code. I mean, how clean is that? The function is even named existe, which is Spanish for exists. It just takes the 3 variables, does the multiplication, and tells you true or false. It's this beautiful, direct translation from a deep idea into working code that makes it so compelling. And here you can see it in action. Look at that first row. Super high probability, totally possible. Yeah, of course, that gets a true. But the second row is what's really interesting. Even though it's completely possible, its probability is just too low. It doesn't clear that 0.1 threshold, so the result is false. It really drives home that possibility alone is never enough. But this isn't just about one-off calculations. The author's vision is much bigger. This has been built out into a full-fledged framework, one that's designed for serious, large-scale use by both the scientific and tech communities. And when I say serious, I mean it. This isn't just a script, it's engineered for performance. It uses object-oriented models to track tons of different phenomena all at once. It's vectorized for high-speed processing with tools like NumPy. It can even run complex Monte-Carlo simulations to see how systems evolve. And, maybe most importantly for science, it has traceability built in, so every result can be audited and reproduced. This is professional-grade stuff. Okay, so we've got the theory and we've got the code. But what's the point? What can you actually do with an equation for existence? Well, it turns out this provides a whole new lens for looking at some very real-world problems.
The potential uses are incredibly broad. In AI, you could use it as a sanity check to see if a machine learning model's prediction is even plausible. In science, you could literally assign a score to a new hypothesis to gauge its viability. You could bake these rules into blockchain smart contracts, use it to assess the risk of a new business venture. You could even use it to design the rules for how things behave in a video game. You can really see the practical, in-the-weeds thinking that went into this from little notes in the documentation, like this one. It points out that for something like blockchain, you have to use fixed point integers, not floating point numbers, to guarantee that your results are always the same. That's not a philosopher talking. That's an engineer thinking about high-stakes, real-world systems. So after diving into the math, to the code, and all the ways we could use it, what's the big core idea we should walk away with? It all comes down to this. Existence isn't just a simple yes or no. It's a product of what is logically possible and what is statistically probable. By weaving these two massive ideas into a single, testable equation, we've been given a powerful new tool to model, to test, and maybe to better understand the world around us. And that leaves us with one final, absolutely fascinating question to chew on. Now that there's a formal, computational framework for existence on the table, what parts of our reality should we put to the test first?